Welcome back. I hope you're doing great. In the previous lecture, we understood what is the life cycle of a Spark application outside the Spark. In this lecture, we'll understand what is the life cycle of a Spark application inside the Spark. As we learned, life cycle outside the Spark application is more of allocation of the driver process and executors to the driver. So it all started with a user submitting a application code, that is a Spark application code. It is very important to know what exactly happens within the Spark. Let us look into that now. As we know, when you submit the Spark application, it has to go through Spark session. So first step for any Spark application is creating the Spark session. We already understood that if you are executing the code in interactive mode, Spark session is already available. But in application, you got to create the Spark session manually. So this is how you create the Spark session. Spark session dot builder master. You have to provide the app name. You have to say get or create. This is how you create the Spark session. After you have a Spark session, you should be able to run your Spark code. From the Spark session, you will be able to access the low level APIs as well. But as you know, we have Spark context within the Spark session. So we have two things. One is Spark context and also SQL context as a part of the Spark session. Before 2.4, this one and this one are separate. After Spark 2.4, both of them are combined into the Spark session. As we already understood, Spark context is the one which represents the connection to the Spark cluster. And through the Spark context, we will be able to communicate with the Spark low-level APIs. If you have gone through the RDDs and distributed variables, we always use the Spark context to create the RDDs, broadcast variables, and accumulators. Through the Spark context, we'll also be able to run the code on the cluster. So a Spark context is one of the important component within the Spark session to run the code on the cluster. So we understood whenever we write a Spark code, we need to ensure that Spark session is created. The Spark context is the one which is responsible for communicating with the low level APIs, and even through that we'll be able to run the code on the cluster. But if I ask you a question, primarily Spark code consists of what? Can you just recollect? It consists of transformations and also the actions. So now understanding how the declarative instructions like transformations on the data frames are converted into physical execution plans is very important to understand to know what is the life cycle inside the Spark. Let us try to understand that now. When you submit an application, each application, we are talking about a Spark application here. Each application would have one or more Spark jobs. And these Spark jobs are executed serially. Means let us say job 1, job 2, job 3. They are not executed parallelly. They are executed one after the another. We understood application is made up of one or more Spark jobs. Actually, what happens is your application would have transformation 1, transformation 2, transformation 3, you have action 1, action 2. So for each of the action, there is one job. The action can be your collect, save, anything, any action you know. And within the job, we have different stages. It may have one or more stages within the job. And within the stages, we may have one or more tasks. So the sequence is for each action there is a job. Within the job we have stages. Within the stage you may have tasks. This is how your logical code is converted into the physical execution plan through job stages and tasks. Let us understand what is job, what is stage, what is task in bit more detail. What is job? A job in Spark is nothing but a parallel computation of multiple tasks that get triggered when there is a action from a Spark. It is created in response to the action. Action can be save or collect. When you submit a Spark application, driver converts your Spark application into one or more Spark jobs, which we already discussed. Then it transforms each job into DAG. DAG is nothing but directed acyclic graph. Spark follows the steps in the DAG and executes your code. I hope the job is clear now. Let us move on to the stages. What are stages? Stages are nothing but the groups of tasks that can be executed together to compute the same operation on multiple machines. We already understood we have a job that will have stages, that will have tasks. This is nothing but a group of tasks. These group of tasks can be executed together to compute the same operation. That is what the stage is. What Spark does is Spark will try to pack as much work as possible into the same stage. What does it mean? When I say work here, I'm talking about the transformation and actions. While Spark tries to pack as much as work as possible into the same stage, Spark engine starts the new stages in case of shuffles. We already know what is shuffle. Shuffle happens whenever there is a physical repartitioning of the data. Like when this physical repartitioning or shuffle happens, let us say whenever you want to sort the data frame, or whenever you are trying to group the data. So in those cases, shuffle happens because it requires sending up the records from one node to another node. So whenever there is a shuffle, Spark starts a new stage for each shuffle. For each shuffle, there is a new stage created. So now we understood what is job, what is stage, then what is task. Task is nothing but a single unit of work or a execution that will be sent to a each Spark executor. Instead of saying a work or execution, you can say task is just a unit of computation applied to a unit of data. When we say unit of data, we're talking about the partition here. As we know, each stage is comprised of Spark tasks, like one or more Spark tasks. We have stage, we have job, we have stage. Each stage is comprised of one or more tasks. Each task maps to a single core and works on the single partition of the data. Let us say you have one big partition. You will have only one task. Let us say your data is split into multiple small partitions. Let us assume we have 1,000 partitions. So you will have 1,000 tasks. Wonderful. We understood what is a job, what is a stage, and what is a task, and how job, stage, and tasks are interrelated. Let us take one example with creating a data frame and subjecting that into the transformation and having an action, and understand how job, stages, and tasks are created.